Welcome to Your Science Connection. This talk show was live streamed on the internet back in 2007. It was born from my blogs, which were based on quantum physics, and the blogs were syndicated all over the internet, and a person who had a talk show lineup offered me a talk show on his lineup, and after reviewing the shows that he syndicated, I opted out of the invitation and I began Your Science Connection on my own from a rented server and would live stream talk shows. And it caught the attention of popular science magazines, Discover magazines, and Scientific American as they were looking to sponsor the show. But I went into hiatus, and a little bit of stuff on the quantum physics front that made me want to come out of retirement on this show, but I held back, and as it is now, we are going to restart the show, and I honestly don't know how long we'll be doing it, but it will always be available here on this channel. So, getting right along, what really made me want to come back and do the show again was the discovery of Higgs Boson. But before we can talk about Higgs Boson, let's first of all get an understanding of what a boson is. Bosons, of course, is a particle. It's a subatomic particle, and basically there are two particles that comprise the nucleus of an atom. There's fermions and there's bosons. Okay, a fermion is a particle with an odd half integer spin, such as 1/2, 3/2, so forth. You know, it has an odd integer spin. And quarks, leptons, and other composite particles like protons and neutrons are fermions. Okay, so bosons are the particles that have an integer spin, a full integer spin, a whole number, in other words. And all force carrier particles are bosons. These are particles that have an even number of, of a spin. The nucleus of an atom, it is either a fermion or a boson depending on the total number of its protons and neutrons as well. So that is basically what a boson is. Now, we do know that for years physicists have been trying to figure out what gives a boson or particles, what gives atoms, bosons, particles, all this, what gives them mass. Like we know that there's different forces that affect mass. So there was a race to figure out what it was that gave atoms their mass. Well, we've known for a long time that there were in space that there are invisible inhabitants. There's radio and television waves, the Earth's magnetic field, gravitational fields, and so on and so forth, and none of it is unchanging. None is uniformly present throughout the universe either. Well, here is where the difference lies with the Higgs field. It is fundamentally different. We know that particles have mass, but when they do the math, it didn't quite make sense. So when they modified the equations to account for the fact that particles have mass, the mathematical harmony was not, it became inconsistent. So if you can imagine all of space filled with an invisible substance, which is now called the Higgs field, it exerts a drag force on particles, and when they accelerate through it, it pushes on in an effort to increase its speed, and this drag force or resistance we would interpret as the particle's mass. So imagine, if you would, imagine a ping pong ball submerged in water. Okay? if you push on the ping pong ball, it feels a lot more massive than what it does outside of the water. And because of this environment that it's in, it endows its mass. Okay, so that is what we can imagine particles submerged in the Higgs field. Okay, so imagine that in space, the Higgs field is water in the pool. And so we also know that Higgs boson represents a new form of matter. Well, there was a race to try to discover this Higgs boson, or also, also called the God particle. And there was also a particle accelerator called Fermilab in Illinois. And its sole mission was to try to discover and prove that Higgs boson existed. Well, and then CERN became born in Switzerland. The Large Hadron Collider was built specifically to discover Higgs boson. And here we have pictured the result, the particle they discovered, which they attributed to be Higgs boson. And the thing about Higgs boson is, as stated before, it's a new form of matter. It doesn't speed up or slow down over time. Its electrons and quarks all have the same spin value. Unlike other fundamental particles, it would have no spin at all. So this of course led to the Nobel Peace, this of course led to the Nobel Prize being awarded to not only Peter Higgs, who theorized that this particle existed and that it gave mass to atoms, but it's also called the God particle because it's believed to be the exact particle that created the universe. You go back to the Big Bang Theory, and all this was believed to have came from this particle. Alright, and we'll probably touch off and on this, the Higgs boson and all this stuff as the show progresses in other shows. But this discovery here is what made me want to resume doing this show. And I'm going to bust off the Did You Know early. Usually I would embed it in the show, but I do have an interview coming up and that I'm going to present, and I would like for to present Did You Know now, so that we can move on to this interview. There's this funny looking creature, and it's like a hodgepodge of many different animals. Okay, it is part duck, part beaver, and part otter. What is this thing? When scientists first discovered this and was examining it, they actually believed it was a hoax. And it is the duck-billed platypus. It's swims very good, this animal does, but it's kind of awkward on land. But it's a very graceful swimmer. And it basically scrounges. It's basically a bottom feeder. But did you know that it has a stinger, that the males have a stinger in the rear of their feet, and that they can administer lethal doses of poison? So even though they're cute and cuddly, you want to try to avoid them as much as possible. I wanted to bring back an interview at some future show, the one that started this whole show, and it's the pilot show that I wanted to bring back, but I only wanted to bring the interview of that show back. And it was Professor Paul Halpern from the University of Sciences in Philadelphia, author of the book What's Science Ever Done for Us? What the Simpsons Can Teach Us About Physics, Robots, Life, and the Universe. This was a very popular interview, and it was the one that set in motion the talk show Your Science Connection. A very good interview, a very good book, still available. Check Amazon or your local bookstore. And now I will bring you my partner in crime. He is him and I joined in a partnership we both had tech companies. I had Teslatronics of Shawnee, Oklahoma. He had Mad Scientist here in Shawnee. And we decided to merge companies and become one, so that we can bring the people of Oklahoma City and surrounding areas the best technology company in the state of Oklahoma. He is my partner in crime. He is Chris Radford, and we are the Mad Scientist. And what I'd like to bring to you today is, what the heck is falling from our sky? What is chemically involved in this stuff that we are calling snow? Because it has very peculiar behavior, very strange characteristics. And now we will go to the interview with Chris Radford of Mad Scientist. There we go.
Welcome to the Mad Scientist.
So we're going to go get some snow.
I'm just looking like a fool. It's a little frozen, as it should be.
Okay, so explain why we're playing with snow.
Well, we're explaining the play with snow because we found something that's a little interesting. Because usually when you burn or take a flame to ice, it does what? It melts. And this stuff, I got a better lighter somewhere. There it is. Old Faithful Bic. This stuff just reacts a little different than what I've ever seen before. Let's pull it up and melt it from the bottom. That way everybody can see there's no water dripping off of it. Should be like pouring down water, you know? But it's not. It's just reminds me of styrofoam. It smells like styrofoam when you burn it. And that should be dripping water on my lighter there. But as you can see, there's no water coming off of that. It's not doing nothing but burn it. No water. This is not.
Still no water.
This is not a trick. There is no water coming off of that.
Wow.
That is amazing. Okay. It's interesting. Now, this has been in there for what? 4, maybe 5 hours now?
Something like that.
And that should be completely melted. What's interesting is if you take ice this big and you put it in this container, then you have 50% of the mass that was there will turn into water, right? It'll all melt down because when water freezes, it expands. And when it melts, it goes back to its normal state there. That probably will still be looking just like that tomorrow morning when we come back into the office. Maybe a little bit farther down than that, but might be exaggerating a little bit, but that's just a little crazy. Seen a lot of YouTube videos of people complaining about the ice, or the snow, not melting like it should. So it made me do some experiments of my own. And I have a lot of theories, but nothing I can prove. And the fact that that just feels different.
It feels like plastic.
Yeah.
Feels like
it smells like plastic when you melt it. It smells like burning plastic. It's crazy. I've never seen anything like it. I see a lot of YouTube videos about it. Nobody's really explaining anything. No one's done a chemical analysis of it to see if there's anything in it. Who knows what it is. We would like to go further and do more research and find out what exactly are they putting in the snow in the United States. Makes it different. What are they putting in the water in the canister? You know, it's like, hey, who knows what it is. But here at the Mad Scientist, we like to figure all kinds of things out. We fix electronics and stuff, but now we're going to try to fix the snow. We'll see how that works out.
Nice.
We're going to probe it. Now, you want to see what it looks like under the imager?
Yeah.
Let's check it out. And we'll take a lighter with us too. And good old faithful Marlboro cigarette, because we're going to get the snow addicted to nicotine. What I don't understand is this was a perfectly clean container. That container was real nice and clean when we put the snow in there, and that just looks really nasty. Got black stuff in it and
Black stuff.
Black stuff. And you see those little, what is this? I mean, it just looks like little wads of hair everywhere. I'll zoom in a little bit more. What exactly? Come on. Too much shaking of the water here. Okay, so what exactly is that? It's not hair, you know, because that is really small. Let's see, we'll back out of it here. We'll just look at it real quick.
Let's show how the imager works. The circuit board behind. Show how small it is.
Oh, okay.
Yeah.
All right. Yeah, we'll show you. This is a iPhone 4S motherboard, or logic board is the correct way to say it. And
put it in palm of your hand.
As you see, how small it is. This is a really cool device. This allows us to look at our electronics when we go to fix it, and just see how bad a shape it's in. And we'll just take it down in there and zoom in, and so you can get real close, you know, and you can change the spectrum of light of which you look at it in, which is kind of cool, I guess, you know, if you like black and white things. And this is like overexposed, but we'll go to the normal. So as you see, it allows us to look at very small stuff on a nice high definition picture there. See, those are itty bitty. Let me find, I'll put my finger and I'll point at it. I'm getting closer. See, my finger is
it's
so
huge.
It's huge, man. You see, look, you see, there's the finger. Let's look at the fingernail. Look at the dirt underneath the nail. Oh, we're not focusing very well. Oh, look at that. And you see the skin real well, don't you? It's a monster. Oh. Okay, enough playing with that. Now let's look back at this stuff we call H2O. It falls, when it freezes and falls. What is this shit here? It's all in it everywhere. And we'll go through, we'll look around. See, it's everywhere. It's bonding to everything. It's everywhere. We'll shake it so you can see. There you go. Look at that. It's just everywhere. What is that crap? You know. Now that looks like a pubic hair.
It looks like a hair.
That one, I would say that's a hair. I'm pretty sure that's a hair. Probably one of these facial pubes fell off in there, but these little bitty ones, like this here, I mean, just look at it. It's crazy looking. What is that? Is it shaking around a little bit?
Wonder what color it would come up on a flame test.
Ooh, that's a good idea. Alright, back to Health 101. Let's see, we should be right about there. We're going to grab this little bit of stuff here. And it's on the tweezers. So we'll move this forward. And we'll set this down. And we'll go to it. So you can see that hairy looking crap that was in there is right there on the very, 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 very tip. We'll zoom in a little bit more there. As you can see, looks like some kind of tar. But as you see it in the water, it looked like little stringy fingers of cubic hair. But let's see what it does. Let me take a flame to it. Yes, stand back. Where it's a little hotter. Doesn't seem to be.
This is not burning at all.
It's not burning at all. Where are we at here? Of course, we carboned up the rest of the rugby. But look at that, shit's still intact. It didn't burn. I don't know if I should do this right here, but we're gonna try it. Let's see if it goes back into the water as a free animal. Where are we at here? Before I... trying to find out where... There we are, there we are. With the rest of it.
It's melted. It's not coming off, is it?
Mm-mm.
Look at that.
What is that? I'm trying to rub it off. Let's get it there. Let's take the tweezers and slide in there with that. Let's see here. Oh God, it's hard to do this. What is that? Look at that.
That is strange.
What is that stuff? Oh, it's floating now. Oh, there it is on the surface right there. Right there it is. See it floating right there? Let's leave it on it a little bit. Messing with the autofocus there. There's a lot of things in that water. What is all that stuff?
Let's look at what we melted. What we tried to melt.
That's a good question. Let's turn it over. Let's bring this into view.
Looks glassy, dude.
It just doesn't want to focus for one. Well, you are too close. Let's break this down a little bit. That's probably easier said than done. So we're just gonna.
We should explain on the flame test. Different colors denote different elements. For instance, hydrogen is purple. And what causes it to change colors is the electron transferring from the ground state to the outer shell back to the nucleus. The result, the flame color, is when it's trying to become stabilized again.
Let's burn this little Burn this mother liver down, Pookie. Most of that water that's on there is from being in there a while ago. Yeah, it's burning my fingers. It's pretty hot.
It is dripping somewhat.
Well, because it's soaked in water. A little interesting there. I just want it to sit just right.
It's tarry looking, ain't it?
Yeah.
What's it feel like
It
to you?
feels like a melted glass or plastic.
It doesn't
It's
feel
really
like
slick.
ice. It doesn't feel like burnt ice, does it?
No. Usually when I think you can get the same effect on an ice cube of it being darkened like that from the lighter, but usually I wish I had some ice here to compare. I might have some in this freezer.
Still, it wouldn't be tarry like that.
No.
That is tar looking.
I don't have any ice. Let's see. Now let's burn some plastic, shall we? Let's see if we get the same effect from some plastic, because this is exactly what it feels like. Would you say? When you touch that surface right there.
Mm-hmm.
So
That's exactly what it feels like.
So let's burn the plastic. And the plastic burns. Alright. And let's look at the plastic in comparison. It smells like wax. Maybe that's a crazy plastic stuff there, you know. Those fumes are good for you, they say.
Mm-hmm.
Look at it still.
It smells about the same too.
Yeah. And it looks about the same.
It does. That is strange.
Let me just... Oh, that's nice and hot. And just in a comparison. You know. Interesting.
It looks about the same.
Yeah. Maybe we should save some and put it under a microscope and look
Like
at
an
it.
electron microscope.
Yeah.
That is awesome.
See what's in it. You know.
So what do we know? We know it's... What is it? It's not snow. Is it?
It doesn't react like snow. Before I would take snow, put it in your hand, it would melt easy. And of course it's all off the parking lot now, you know, bunched up and compressed. I would like to take a sample like we did earlier today. I think it would look better than this ball of ice right here that we're trying to melt, because it's already melted together somewhat. And yeah, you know, we can improve the experiment for sure and find out better ways to do, which we're doing, but you know, we are busy people, so we don't get to play like everybody else. And that's how you successfully knock a lighter off of a counter. Alright. What else should we talk about?
That's it on the snow.
Isn't that interesting?
That is interesting.
Raises the question.
What is
What are
it?
they putting in the snow? Is it chemtrails? Is it conspiracy theories? That I love conspiracy theories too, because there's so many on YouTube. There's so many people out there that have really good ideas, but they're going the wrong direction with it, I think. Is geoengineering have something to do with this? Who knows? Stay tuned and we'll find out. And we'll put a stop to it if we can here at the Mad Scientist. We got a little fire going.